Hey class, this is a short video on sine, cosine, tangent. So let's jump right into it. You have a triangle like this, and you know the angle here. Let's say this is a 15-degree angle, and you know this right here, this is 17 feet long or inches long or whatever your unit is, and you want to find x. Okay, so how are we going to do that? So the first step is you have to label your sides. And here are your choices for labels. You can label a side either hype, op, or adjacent. So you can choose one of those three labels for the sides. Now I always start with hypotenuse. Hypotenuse is the side that is directly opposite from the right angle. So here the 17, we're going to call this our hypotenuse. The opposite side is the one that's across from the 15-degree angle. So for this one, let's just think of this leg and this leg. These two legs form the 15. Think of these as two arms reaching across. Here are the fingers on the end of the arms. They're reaching across, and they're reaching across to hug this letter X. It's the opposite side. And then the last one is the adjacent. So we've got hypotenuse, opposite, adjacent. Now the second step on this is we have to choose one of the ratios, and we can choose from sine, cosine, or tangent. Now how do we know which of these funny little words to use? Well, each of these has a specific definition. Sine is defined as the ratio of the opposite side and the hypotenuse. Cosine is the ratio of the adjacent side to the hypotenuse. And finally, the tangent is the ratio of the opposite side to the adjacent side. So we're going to take a look at our triangle, and we have to choose one ratio. Now it's helpful to decide which side we don't care about. We definitely care about the opposite side because this is what we're trying to find out. We're trying to find that x. So we definitely want a ratio that has the word op in it. We also want to use the fact that we know the hypotenuse. The hypotenuse is 17, so we want a ratio with opposite and hypotenuse, and we don't really care about the adjacent. We don't know what it is, and we're not trying to find out what it is. So just a ratio that has opposite and hypotenuse. So I'm looking through this, and good luck, we found it on the first one. It is the sine ratio. So we're going to write the word sine, and it's the sine of this angle. Our angle here is 15. The sine of 15 is equal to the opposite over the hypotenuse. So it's the opposite on top. Our opposite is x, and then we got 17 on the bottom. Okay, the third step is we just have to do a little bit of algebra here. And we want to get the letter x all by itself, and to get x by itself, we have to multiply both sides by 17. Multiply that side by 17. Now the 17 and the 17, these cancel each other out, leaving behind just x equals whatever 17 times the sine of 15 is. And at this point, it's just a calculator question. All right, so let's go down and do a different question. So this one, I want you to try this one on your own. So let's say this is 37, and this is 11, and we're trying to find that side x. Okay, so go ahead and walk through those three steps. Number one, you're going to label your sides. Number two, you're going to choose whether sine, cosine, or tangent applies. And number three, you're going to do a little bit of algebra. Okay, so hopefully you've had a chance to do this already. We're going to label our sides. This longest side here is our hypotenuse. This side across from the 37, these two legs make the 37, and across from the two legs is our opposite side, and this is our adjacent. So in this case, we don't care about our opposite side because we don't know what it is, nor are we trying to find out what it is. We just care about hypotenuse and adjacent. So looking through the notes, the ratio dealing with hypotenuse and adjacent is cosine. So we write cosine of 37 is equal to x over 11. With a little bit of algebra, multiply by 11, multiply by 11, those cancel, And your answer is 11 cosine 37, which you'd plug into a calculator and you get some kind of decimal, which you'd round to 1 or 2 decimal places, whatever it's asking you to do. All right, let's do another one. Let's draw this triangle out here. Okay, so we've got this triangle. And let's say we know this angle here at the bottom is 39. And this is 15. And we're trying to find x. Okay, so what are we going to do? So again, label our sides. This is hype. This is op. This is adjacent. We don't care about the hypotenuse, and you choose the ratio that deals with opposite and adjacent, and that is the tangent ratio. So we're going to say tangent of 39 degrees is equal to opposite, which is x, over adjacent 15. With a little bit of algebra, multiply that by 15, multiply that by 15, and you get your answer. X is 15 tan 39. Okay, I want to do another one where the algebra gets slightly tricky. So let's draw this triangle out. Let's say this is x, and this is 24, and this is 71 degrees. Okay, so we're trying to find x here. So again, we label our sides. Because this is the right angle, across from it is our hypotenuse, x. This is our opposite side, and this side is our adjacent, which we don't care about. So the ratio dealing with opposite and hypotenuse, that's our sine ratio. So we write sine of 71 is equal to the opposite over the hypotenuse. Now we can do some algebra here to get x by itself, but there is this nifty little trick that I want you to memorize. We can change places between this term and this term. So we can rewrite this now as x equals 24 over the sine of 71. Let me just prove to you that that trick works. Let's say you have 2 is equal to 6 over 3. You can do the same thing by switching these guys out. And you can say that 3 is the same thing as 6 over 2. See how we did that? So it works out, and you can do it here. You could also do this with some algebra, where I could multiply that side by x and that side by x, and then you'd have x sine 71 equals 24x. And then if you divided both sides by sine 71, then you would get to the step. The x would come here, and 24, yeah, you get that. Same way. But again, the fast way here, guys, is the shortcut. Let's say you have like cosine 54 equals 7 over x. Just switch those guys out and say x equals 7 over cosine 54. Okay, so now let's spend a second talking about inverse cosine, inverse tangent, and all that good stuff. So let's suppose you make a skateboard ramp. And your skateboard ramp is 3 feet high over 12 feet. And you have a friend that comes to visit, and he says, wow, this skateboard ramp's awesome. I love the angle. I want to make it something exactly the same with the same angle. And he says, what angle is your skateboard ramp? And you're like, I never really thought about it. I just built it, and it kind of looked right. But let's figure out if we can find out the angle. It's the same process we do before. We're going to label the sides, hypotenuse, opposite, adjacent, just the same way. Now, after this, we have to decide which side we don't care about. In this case, the hypotenuse doesn't help us. And now we choose our ratio. The ratio that has the word op and adjacent in the same fraction is tan. So we're going to say tan x is equal to opposite on top, adjacent on bottom. So here, what we're trying to solve for is the letter x. We're trying to get that letter x all by itself. So how do we isolate that variable? Let's go back and take a look at kind of an unrelated example. Let's say we have this question. The square root of x equals 4. How are we going to find 4? Well, how do we undo square root? Square root and squared are opposite operations. They're inverse operations. So the square root sign and the squared sign, those two signs cancel each other out, leaving behind just x equals 16. So we want to find the inverse operation of tangent. We want to find what x was before it got tangented. We want to untangent it. So the operation to untangent it is called inverse tangent. And it has tan with a little -1 there. So if we inverse tangent, inverse tan and tan, they cancel each other out, leaving behind what I really want is the letter x all by itself. But if we inverse tan one side, we have to inverse tan the other side. And so we're going inverse tan of 3/12. Now what your calculator is thinking here is, or what you're asking your calculator to do is, tell me the angle that's created when this is a 3:12 ratio, when the ratio of opposite to hypotenuse is 3:12. And your calculator is going to come back and it's going to give you some angle there. Okay, so for this one, go into Desmos Scientific Calculator. You want to hit the button that says FUNC, func, short for function, and that will open up the inverse tan, inverse cosine, and inverse sine. Let's do one more inverse question just so you have some time to practice. So I'd try this one on your own. Okay, so we got 8, 17, and x, and this is clearly not drawn to scale at all. Okay, so hopefully you had a chance to solve this out. This is our op, this is our hype, and this is our adjacent. So we decide op is not going to help us here. Hype and adjacent is cosine. So the cosine of x is equal to adjacent on top, hypotenuse on bottom. Now we want to get rid of that word cosine, so to uncosine it, we do this inverse cosine. And if we uncosine that side, we have to uncosine 8/17. And so uncosine and cosine cancel each other out, leaving behind x. And so x is inverse cosine of 8/17. And of course, if you were doing this on homework or a test, you'd plug that into a calculator and you'd get some kind of number right there. Okay, guys, hopefully this was helpful for you. If you got any questions, just shoot me a message on Canvas or email.